In this video, we'll take a look at what's called the modern view of atomic structure. So we see some of the scientists listed from the previous video that discovered protons. We see Rutherford in 1919, neutrons by Chadwick in 32. We hadn't mentioned that prior, but now we know who discovered the neutrons or who's credited with that. Um, we can also see here in modern times that we now agree that protons and electrons are the only particles that have a charge. Specifically, protons we say have a +1 charge, electrons have a -1 charge. That's seen over here in this summary table. The neutron is neutral, it has no charge. We also see that protons and neutrons have almost the same mass, so you won't need to memorize these values or the unit here, the atomic mass unit, but it's just shown to compare that they're almost the same size, almost the same mass. One's positively charged, one's neutral, but then the electron here is much smaller. So by comparison, this is 5.486 to the -4th atomic mass units. So the mass of an electron is so small that when we calculate what's called a molar mass, or the mass of the atom or the mass of an element, we tend to ignore the mass of the electron. So another thing to think about here are the symbols of elements, and depending on what element we're talking about, it may have a one letter symbol for say carbon here, or we could have a two-letter symbol. So copper is from a different language. It was cuprous or cupric. So that's where the Cu comes from for copper. So we have either a one or two letter symbol, and the first letter is always capitalized, the second is always lowercase. So we have these terms here: atomic number, or the Z number, which is the number of protons. So number of protons in our atom. And all atoms of the same type have the same number of protons. So same number of protons for all carbon atoms, but the mass number may be different depending on the number of neutrons in the specific isotope. So the mass number is going to be both, it's commonly abbreviated A here, and it's going to be both the number of protons and the number of neutrons. So the mass number, when we abbreviate a specific isotope, is going to be the top number here. So if carbon has 6 protons and 6 neutrons, we would call it the specific carbon-12 isotope here. So the atomic symbol of the element C is shown here. 12 for the mass number of both protons and neutrons, and then just the protons down here is the atomic number, the Z number. So as noted, isotopes are atoms of the same element, so same element, but they have a differing number of neutrons. Remember, the protons, the number will always be the same. They define the atom or the element type, and then the number of neutrons can vary. So we'll continue with sample exercise 1 and 2 in the next video.